Welcome to lesson 10. We're going to model a situation and decide what type of equation it is. We have an example here where we have Andrew who has some money and he has invested it. And we are going to figure out what kind of function best represents this particular table. So we have our two variables. V stands for the value in hundreds of dollars, and T stands for time and months. And I like to write these out to the side just so I don't have to reread the whole problem. And then we're going to figure out what kind of modeling would be best for the situation. We have three options really: linear, exponential, or quadratic. And so you remember what makes a function linear, you remember what makes a function exponential, and I hope you can remember what makes a function quadratic. So now we're going to look at the differences and changes in x and y values. I notice that my x's are going in a constant increase by 2, and now I'm trying to figure out what my rate of change is with my y values. So initially from 325 to 385, I'm adding 60, and basically what I'm going to do is try to find how one value changes to the next. And so what you'll see is you'll see me writing these changes, and what you'll notice right away is that they're not the same. So right away we can say they're not linear, and right away we can also say they're probably not exponential because we're not multiplying. This rate of change is not being multiplied or divided by something. So after I do this, in order for it to be quadratic, it has to have two levels of change, and the second level of change has to be constant. So you see there, I can't figure out what this is, but I do notice a trend. Look at the pattern. It is increasing and decreasing by the same numbers essentially, and so what you now see is that they have the same second level rate of change, which is minus 40, and that is characteristic of a quadratic function. So I think definitely a quadratic would be the best model for this. So we're going to do a quadratic regression, and the equation for that is ax squared plus bx plus c. And you can actually do this in your calculator by pressing the values. I've gone ahead and entered all the values, and I'm going to hit number 5. I initially thought it was 4, but number 5 in here to get the quadratic regression, as they call it. Once you do that, it'll actually give you the variables and you can just plug it in. So negative 5 is a, so I'm going to say y equals negative 5 x squared plus 60 for b, x plus 225. So that's the equation I'm going to use. And I'm going to look at the next question. It's asking me what was the starting point. So that means when t was 0, what was the value? Well, now that I have an equation, I can substitute the 0 for the x and get that actual starting value. And when I do that, my starting value is 225. Now this is in hundreds of dollars, so that's my initial investment. That's also going to be your y-intercept, so that's a little tidbit of help for you. Now, my other question is, what would the vertex be here? Or where is the vertex in the graph for this particular equation? Well, we know that my vertex comes from easier looked at when we have the vertex in factored form, or the whole equation in factored form. So that's what I'm doing here. I went ahead and factored out the greatest common factor, and now I'm looking for factors of negative 45 that will add up to negative 12. And I am looking, and I seem to have found 3 and 15. If 15 is negative and 3 is positive, I'm going to find the right combination here. So that's what I'm doing. So I am going to have my intercepts be at 15 and negative 3. Actually, I know it says 3 there. It's supposed to be negative 3. Make sure you note that in your notes. And with that, from there, I can add them up. A 15 and a negative 3 are going to give you a positive 12. Divide that by 2. And your axis of symmetry is going to be at x equals 6. So that means your vertex x value is 6. And you can plug that in to get the y value from there to figure out your vertex. We're going to be doing exercises like this in class. So don't worry if you didn't get it the first time around. We'll get plenty of practice. The main thing here for you is to be able to tell if something is a quadratic equation or not, how to graph it, and answer questions about it.